Hi again. Welcome to a walkthrough of Android programming, Big Nerd Ranch Guide, Edition 4, and we are on Chapter 4. Alright, let me pull it back up on my end. 4. Persisting UI state. Android does a great job of providing alternative resources at the right time. However, destroying and recreating activities on rotation can cause headaches, such as GeoQuiz's bug of reverting back to the first question when the device is rotated. To fix this bug, the post-rotation main activity instance needs to know the old value of current index. You need a way to save this data across a runtime configuration change, like rotation. In this chapter, you'll fix GeoQuiz's UI state loss on rotation bug by storing its UI data in a view model. You will also address a less easily discoverable but equally problematic bug, UI state loss on process death, using Android's save instance state mechanism. Pull up Android Studio on my side. Okay. In a moment, you're going to add ViewModel class to your project. The ViewModel class comes from an Android Jetpack library called Lifecycle Extensions, one of many libraries that you will use throughout this book. You will learn more about Jetpack later in this chapter. To use the class, you must first include the library in the list of dependencies for your project. Your project's dependencies live in a file called build.gradle. Recall that Gradle is the Android build tool. In this project tool window, with the Android view enabled, expand the Gradle scripts section and take a look at the contents. So project. Expand the Gradle scripts section. Gradle scripts. Gradle's a little elephant. The project actually comes with two build.gradle files, one for the project as a whole and one for your app module. Yep, project and module. You'll see something similar to the listing on 4.1. The app, apply plugin, where are you? Gradle dependencies app build.gradle. Oh, it's a little different in this version. Okay. But I see plugins, and then I see dependencies. Okay. The first line of the dependencies section specifies a project depends on all the jar files in the libs directory. However, this one doesn't have that. Given that it's a newer version of Android Studio, I assume. Guidelines were automatically included in your project based on the settings you selected when you created it. Again, no jars because this is strictly in Kotlin, so I'm going to skip that. Going to add implementation to the end of the list. Implementation quote droid x dot life cycle This is reminding me of dependencies in Ruby on Rails, which to me is a disaster. However, other people have no problems with it. So. Am I sure that I'm looking in the right spot? Build.gradle for app. I'm looking at... Yeah, alright. Okay, looks like it should be fine. Android, when you make any change to the build.gradle, Android Studio will prompt you to sync the files. The sync asks Gradle to update the builds based on your changes by either downloading or removing dependencies. To sync, either click Sync Now or File Sync Project. Sync now. The newer version 2.2.0 is available. Fine, fair, but I'll leave this. You can also file sync project. Adding a view model. And we'll go back to view model. Oh, now back to view model. Let me turn down the music slightly. Actually, let me see what level it's at. Oh, it's fine. Make sure, yeah, as long as my mic is fine. Now, back to view model. A view model is related to one particular screen and is a great place to put logic involved in formatting the data to display on that screen. A view model holds onto a model object and decorates the model, adding functionality to display on screen that you might not want in the model itself. Using a view model aggregates all the data the screen needs in one place, formats the data, and makes it easy to access the end result. View model is part of the Android X lifestyle package, which contains lifestyle-related APIs, including lifecycle-aware components. Lifecycle-aware components observe the lifecycle of some other components, such as an activity, or take the state of lifecycle into account. And take the state of that lifecycle into account. Google created the Android X.Lifecycle package and its contents to make dealing with the activity lifecycle and other lifecycles, which you will learn about later in this book, a little less painful. You will learn about live data, another lifecycle-aware component, in Chapter 11, and will learn how to create your own lifecycle-aware components in Chapter 25. Now you're ready to create your ViewModel subclass, Quiz ViewModel. In the project, hold on, let me pull this up. In the project tool window, right-click the com.bignerdranch.android.geoquiz. Package, which is project window. Project, of course. Right click on it, new, Kotlin, Android GeoQuiz package. I need to be in packages, right? I'm gonna do it this way. Right click, new, Kotlin class file, choose destination directory. Project tool window. Oh. Is this the project tool window? I assume this is the project tool window. Well, let me do a new colon here. Alright, fine. We're going back into packages. No, I don't know which one you want to go in. New colon class slash file. It's going to be a quiz view model. Quiz view model. As shown in 4.3. And select class for the kind drop down. Okay. Class quiz view model. Quiz view model. Quiz view model.tk, which I have open. Add an init block and override uncleared. Log the creation and destruction of quiz view model instance as shown. So I want to create private constant value tag, name tag, which is in quotes quiz view model, class quiz view model. Somehow I feel that this isn't pulling right if it is asking me to import here. Whatever, I'll agree to it though. Initialize log.d tag view model instance created. Override function on cleared. Super dot uncleared, of course, and log dot d tag view model instance about to be destroyed. Close. Oop. The uncleared function is called just before a view model is destroyed. This is a useful place to perform any cleanup, such as unobserving data source. For now, you simply log the fact that view model is about to be destroyed so that you can explore its life cycle. Now, on mainActivity.kt, oh, I see. These are in a different location. Yeah, okay. These are sitting in the wrong one. These are sitting in Android test. We move. Okay. This is my problem. I am new Kotlin class file. You need to be... You're not generated. You're not the test. You're not the test either. Okay. Alright, let's fix this. So I shouldn't need to import view model. But I still do? Whatever. I might delete this one. Okay, back in main activity, which I think I have this figured out. Okay. Okay, this is right. I do have it correct. Okay. And main activity KT and in onCreate. Where's the onCreate? I thought onCreate was at the beginning. Oh no, onCreate's here, and this one I instantiate everything. Okay. And onCreate associate activity with an instance of quiz view model. Override set content view. We do it directly after set content view. Got it. Value provider view model provider equals view model providers of this value quiz view model equals provider.get quiz view model class dot java log d tag got a quiz view model. The view model providers class provides instances of the view model provider class. Your call to view model providers of this creates and returns view model providers associated with the activity. So it's any and all. View model provider, no plural, on the other hand, provides instances of view model to the activity. Calling provider.get quiz view model class.java returns an instance of quiz view model. You will most often see this function chained together like so. View model providers of this .get quiz view model class.java. This view model provider acts like a registry of view models. When the activity queries for a quiz view model for the first time, view model provider creates and returns a new quiz view model instance. When the activity queries for the quiz view model after a configuration change, the instance that was first created is returned. When the activity is finished, such as when the user presses back button, the view model activity pair is removed from memory. Okay. View model lifecycle and view model provider. You learned in Chapter 3 that activities transition between 4 states: resumed, paused, stopped, and non-existent. You also learned about different ways an activity can be destroyed, either by the user finishing the activity or by the system destroying it as a result of a configuration change. When the user finishes an activity, they expect their UI state to be reset. When the user rotates an activity, they expect their UI state to be the same before and after rotation. You can determine which of these two scenarios is happening by checking the activity's isFinishing property. If isFinishing is true, the activity is being destroyed because the user finished the activity, such as by pressing the back button or clearing the app's card from the overview screen. If isFinishing is false, the activity is being destroyed by the system because of a configuration change. But you do not need to track isFinishing and preserve UI state manually when it's false just to meet your user's expectations. Instead, you can use a view model to keep an activity's UI state in memory across configuration changes. A view model's lifecycle more closely mirrors the user's expectations. It survives configuration changes and is destroyed only when its associated activity is finished. You associate a view model instance with an activity's lifecycle, as you did in 4.4. The view model is then said to be scoped into the activity's lifecycle. This means the view model will remain in memory regardless of the activity's state until the activity is finished. Once the activity is finished, such as the user's pressing the back button, the view model instance is destroyed. So, figure 4.2, quiz model, scope to main activity. Main activity on destroyed is called. If it's finished, yes, it's destroyed. No, quiz model stays in memory. Quiz view model, got it. This means that the view model stays in memory during the configuration change, such as rotation. During the configuration change, the activity instance is destroyed and recreated, but the view models scoped to the activity stay in memory. This is depicted in Figure 4.3, using main activity and quiz view model. Figure 4.3, main activity and quiz view model across rotation. Before rotation, main activity, quiz view model. During rotation, quiz view model. After rotation, new main activity, quiz view model. So it attaches to the quiz view model. When it's rotated, the quiz view model stays, but the main activity is destroyed. Then after rotation, the new main activity pulls from the quiz view model again. To see this in action, run GeoQuiz. In Logcat, select Edit Filter Configuration in the drop-down and create a new filter. In the log tag box, enter quiz view model main activity. That is the two class names with the pipe character between them, to show only logs tagged to either class name. Name the filter view model and activity, or another name that makes sense to you. I'll click OK. Alright, let's see where this pops up this time. Right side? I'll move you over. Okay, refresh. I'm gonna pull up Logcat. Uncreate bundle. Got a quiz. On start is called. Got a quiz view model. Okay, we now have a quiz view model. And I need to rotate. Got a quiz view model. Is it the same one though? Yes, it is the same one. So I think that's the point, is that it's the same quiz view model, even when this has been changed and moved. Right, it jumps back, but it's still the same quiz view model all 3 times. It's a 9-0. I'm gonna kill it. Let's pull up the app again. Oh, maybe it is the same one still. Yep, it's still the same one. Again. Okay. Quiz view model persists. Right, exactly. Rotate the device. Quiz view model is not new instance of main activity created after rotation. Since the original quiz view is still in memory. Hit your back button. Quiz view model instance is about to be destroyed. The quiz view model is destroyed. Alright, let's see then. No, it's not being destroyed. Got a quiz, got a quiz, got a quiz. It wasn't destroyed. Did I miss a piece of the... Ooh, ooh, ooh. Did I miss a piece of it? Metal instance is about to be destroyed. It definitely didn't get on stop, and then it should be on destroy. It's not being destroyed. Again, maybe this is something about the newer version of Android. That's weird though. Now it's time to fix GeoQuiz rotation bug. Quiz view model is not destroyed on rotation the way main activity is. So you can stash the activity's UI state data in the quiz view model instance, and it too will survive rotation. You're going to copy the question and current index data from your activity to your view model along with the logic related to them. Begin by cutting the current index and question bank properties from main activity. Okay. So in main activity, I'm cutting out question bank. Now paste current index and question bank properties into quiz model view. Removing the init, and I'm removing the override. Next, add a function to quiz view model to advance to the next question. Also add computer properties to return the text, the answer for the current question. Okay, you want var current index equals Okay, there's your quiz view model. We said the view model stores the data that is associated that its associated screen needs, formats it, and makes it easy to access. This allows you to remove presentation logic code from the activity, which in turn keeps your activity simpler. And keeping the activities as simple as possible is a good thing. Any logic you put in your activity might be unintentionally affected by the activity's lifecycle. Also, it allows the activity to be responsible for handling only what appears on screen, not the logic behind determining the data to display. However, you're going to leave update question and check answer functions in main activity. You will update these functions shortly to call them through the new quiz view model computed properties you added, but you will keep them in main activity to help keep your code organized. Next, add a lazily initialized property to stash the quiz view model instance associated with the activity. Okay. Lazy probably means that it's on the fly. Okay. So private value quiz view model, which is right about there you are. No, you're new. Red function on create. So right before the overview function on create. I want a private value quiz view model by lazy. Oh, weird. View model providers dot of this dot get quiz view model :: Java override function. We don't need a value provider, we don't need value quiz, and we don't need the log. Delete. Using the lazy allows you to make the quiz view model property a val instead of a var. This is great because you only need and want to grab and store the quiz model view when the activity instance is created. So quiz view model should only be assigned a value one time. Got it. That's why it's a value. Because it's just grabbing it once. It's not going to change. If it's going to change, it'd be var. Using a blah blah blah. More importantly, using by lazy means quiz view model calculation and assignment will not happen until the first time you access quiz view model, so it is like on the fly. This is good because you cannot safely access a view model until activity.onCreate. If you're trying to call view model providers of this.get quiz model class Java before activity.create, your act will crash with an illegal state exception. Finally, update main activity to display content from and interact with your newly updated quiz view model. So in override on create, next button .set on click listener. We're gonna remove current index. Next button, next button, next button, next button. Other image buttons for me. Gonna remove the current index. So we're gonna do quiz view model dot move to next. Previous function button value. Private function update question. Where are you? question text res ID equals quiz view model current question text. Quiz view model, move to next. Quiz view model, move to next. Move to next. It is in there. Okay. Oh, because we create. Yeah. Right. I typed those out. Check answer. Well, correct answer equals quiz view model current question answer. Okay, I'm just going to remove all of this because it's going to give me too much issue. Because current index is stored currently now in quiz view model. I could do yeah, gross, but it'll work. Run GeoQuiz. I'm adding the quizviewmodel.question bank because hold on, why is it question bank? Question bank. Oh, it's still a private value here. I'm gonna make you public. Alright. Is it public here though? Yeah, but that's okay. But the reason why it's not public, when they had me move it over is because, well, they don't want it to be public at that point. She didn't have to change the previous one though. Okay, it only wants me to try next, so. Alright. Well. Do we have, yeah, we have a function move to next. We do not have a function move to previous though. Will it still run? No. Alright, hold on. This thing misses a whole section. Oop. Call it move to prev. All this work. I could just be sloppy about it, and I think I will, just to test it. No, we shouldn't be accessing them directly. Instead, we should be updating them directly through the other file, but for time's sake, I'm gonna skip it. Alright. Run GeoQuiz. Hit next. And rotate the device. I'm on the Pacific Ocean. I'm going to rotate device. Ta-da! It's still the Pacific Ocean. No matter how many times you rotate, the newly minted main activity will remember what question you were on. Do a happy dance to celebrate solving the UI state loss and rotation bug. But do not dance too long. There's another, less likely, easily discoverable bug to squash. Configuration changes are not the only time the OS can destroy an activity, even though the user does not intend it to. Each app gets its own process, more specifically a Linux process, containing a single thread to execute UI-related work on, and a piece of memory to work on, and a piece of memory to store objects in. An app's process can be destroyed by the OS if the user navigates. Allow me close this so we can see. An app's process can be destroyed by the OS if the user navigates away for a while and Android needs to reclaim memory. When an app's process is destroyed, all the objects stored in the process's memory are destroyed. You'll learn more about Android application processes in Chapter 23. Processes containing resumed or paused activities get higher priority than other processes. When the OS needs to free up resources, it will select lower priority processes first. Practically speaking, a process containing a visible activity will not be reclaimed by the OS. If a foreground process does get reclaimed, that means something is horribly wrong with the device, and your app being killed is probably the least of the user's concerns. But stopped activities are fair game to be killed. So, for example, if the user presses the home button and then goes and watches a video or plays a game, your app's processes might be destroyed. As with this writing, activities themselves are not individually destroyed in low memory situations, even though the documentation reads like that is the case. Instead, Android clears an entire app process from memory, taking all of the app's in-memory activities with it. When the OS destroys an app's processes, any of the app's activities and view models stored in memory will be wiped away, and the OS will not be nice about the destruction. It will not call any of the activity or view model lifecycle callback functions. So how can you save UI state data and use it to reconstruct the activity so that the user never even knows the activity was destroyed? One way to do this is to store the data in saved instance state. Saved instance state is data the OS temporarily stores outside of the activity. You can add values to be saved instance state by overriding activity.onSaveInstanceState bundle. The OS calls activity.onSaveInstanceState bundle anytime the activity that is not finished moves to the stopped state, such as when the user presses the home button and then launches a different app. This timing is important because stopped activities are marked as killable. If your app process is killed because it is a low priority background app, you can rest assured that activity.onSaveInstanceState was already called. The default implementation of onSaveInstanceState bundle directs all of the activities views to save their state as data in the bundle object. A bundle is a structure that maps string keys to values of certain limited types. You have seen this bundle before. It is passed into onCreateBundle ? When you overwrite onCreateBundle, you call onCreateBundle on the activity superclass and pass the bundle you just received. In the superclass implementation, the saved state of the view is retrieved and used to recreate the activity's view hierarchy. You can override onSaveInstanceState to save additional data to the bundle, which can then be read back in onCreateBundle. This is how you're going to save the current index across the process path. First, a main activity.kt at a constant that will be the key for key value pair that will be stored in the bundle. There's not too much left. It's just a bit of a pain. First, the main activity.kt at a constant that will be the key for the key value pair. you're going to be called index. Override to write the value of the current index for the bundle of the constant as its key. Passing by on pause. Unsafe instance state. That's the only thing here. Super on save instance state. So you're passing that up to the super function. You're gonna log I tag unsafe instance state. Saved instance state dot put into key index quiz view model dot current index. So on a save, it's going to save the current index. It's going to put, just put int, it's like put integer. Inserts an integer value into the mapping of this bundle, replacing any existing value for a given key. So it's going to assign it to a key, and it's going to say this key is assigned to this index value, and it's the current quiz index value. Got it. Finally, in onCreateBundle, check for this value. If it exists, assign it to current index. Okay. How do you check if it exists? Function onCreate. Value current index equals save. Is it main activity? Key index. Okay, and then you store it into it. I was gonna say this won't work unless you put that into the quiz view model. So okay. onCreate accepts a nullable bundle as input. This is because there is no state where the new instance of the activity is launched by the user first time. So in this case, the bundle will be null. When the activity is recreated after rotation or process death, the bundle object will be non-null. The non-null bundle will contain any key value pairs you add in onsave instance state bundle. The bundle may also contain additional information added by the framework, such as the contents of added text or other basic UI widget state. Rotation is easy to test, and luckily, so is a low memory solution. Try it out now to see for yourself. On your device or emulator, find and click the settings icon with the list of applications. You need to access the developer options, which are hidden. If you're using hardware, you may need to enable the blah blah blah. If you're using an emulator, System, about, tablet, scroll down, build number 7 times in quick succession. When you see you are a developer, use the back button, scroll down, developer options, many possible settings. Don't keep activities. Destroy every activity as soon as the user leaves it. Now, run GeoQuiz, press next. Press the home button. Pressing the home button causes the activity to be paused and stopped as you know. This log shows the activity has been destroyed, just as if the OS has reclaimed it from memory. However, as the log shows, unsafe instance state was also called, so there is hope. Restore the app using a list, see whether your instance was saved. Alright, let's try it. Yep, unsafe instance state was saved. However, the app is going to work, so let's kill it. Oh, get out of here. What? Am I crazy? I know how to do this. System. About your device. Oh, duh. Okay. Apps don't keep activities. True. Okay. Unsafe instance state was called right before on destroy. Perfect. That's exactly what I wanted. I'm gonna switch to the Pacific Ocean. It's destroyed. Gonna go back in. I'm still in the Pacific Ocean. Got it. That's exactly what I wanted. Be sure to turn don't keep activities off when you are done testing to cause performance increase. Yep, it's still in Pacific Ocean, so we're good. Developer options. I'm going to turn that back off under apps. Where are you? Apps, where are you? Trying, hardware, media, monitoring apps. Okay, we're good. Yes, I understand uncreated gets stashed. When it's stashed, the activity does not exist, but the activity record lives on in the OS. Yes. This is just talking about how unsafe instance state works. So when does the activity record get snuffed? When the activity finished, it really gets destroyed once and for all. At that point, your activity record is discarded. Activity records are also discarded on reboots. ViewModel versus saved instance state. While saved instance state stores an activity record across process death, it also stores an activity record across configuration change. When you first lost an activity, the saved instance state bundle is null. When you rotate the OS calls unsaved instance state bundle to your activity. The OS then passes the data to your stash in the bundle on create bundle. If saved instance state protects from both configuration changes and process death, why bother with a ViewModel at all? To be fair, GeoQuiz is so simple that you could have gotten away with saved instance state only. However, most apps do not rely on a small hard-coded question of bank data to set like GeoQuiz does. Most apps these days pull dynamic data from a database, from the internet, or from a combination of both. These operations are asynchronous, can be slow, and use precious battery and networking resources. And tying these operations to the activity lifecycle can be very tedious and error-prone. ViewModel really shines when you use it to orchestrate dynamic data for the activity, as you will see firsthand in Chapter 11 and Chapter 24. For example, ViewModel makes continuing a download operation across configuration change simple. It also offers an easy way to keep data that was expensive to load in memory across a configuration change. And, as you have seen, ViewModel gets cleaned up automatically once the user finishes the activity. ViewModel does not shine in the process death scenario. As of this rating, the Android team is actively working to improve the developer experience using ViewModels. Lifecycle ViewModel Save State is a new library that was just released to allow ViewModels to save their state across death. This should alleviate some of the difficulties of using ViewModels alongside saved instance state from your activities. So it is not a matter of which is better. Several developers use saved instance state and ViewModel in harmony. Okay. In this chapter, you squash GeoQuiz's state loss bugs by correctly accounting for configuring changes and process death. In the next chapter, you will learn how to use Android Studio's debugging tools to troubleshoot other, more app-specific bugs that might arise. For the more curious, Jetpack, Android X, and Architecture components. The Lifestyle Extensions library containing ViewModels are part of the Android Jetpack components. Android Jetpack components, called Jetpack for short, is a set of libraries created by Google to make various aspects of Android development easier. You can see a list of Jetpack libraries at developer.android.com/jetpack. You can include any of these libraries in your project by adding the corresponding dependency to your build.gradle file as you did in this chapter. Each of the Jetpack libraries is located in a package that starts with Android X. For this reason, you will sometimes hear the term Android X and Jetpack used interchangeably as a checkbox for Android X artifacts. In every case, you should enable this option. This will add some initial Jetpack libraries to your project and set your app up to use them by default. Jetpack are broken into 4 categories: foundation, architecture, behavior, and UI. Okay, skip. Okay, there are no extra questions, no extra hard tasks on this one, so I'll leave this as is. Thank you for tuning in. Next time we'll be going through Chapter 5, Debugging Android Apps. I'm not excited about this one, but should be interesting. Stick around.